This video is about exo and endothermic reactions. So this question says a reaction occurs and energy is absorbed. Is the reaction exo or endo or exothermic? Well, let's think about what's happening. So we have endothermic reactions and exothermic reactions, and we're going to figure out what goes with each type of reaction. For endothermic reaction, endo sounds like enter. Energy enters or is absorbed. That means that at the end, more energy is stored in the bonds than there was at the beginning. So there's more energy in the products than in the reactants, and that's for endothermic reactions. If we were to sketch a graph of this, if we have the reaction progress on the bottom, energy on the y-axis, we'd have the reactants, activation energy, and then the products. And the products would be higher than the reactants. So another thing for endothermic is delta H, and that's the change in enthalpy. For delta H for endothermic, we're gaining energy in those chemical bonds, so delta H is positive. So anytime you see a positive delta H, that's endothermic. All right, let's look at exothermic. For exothermic, it's kind of the opposite. Energy is going to exit. Energy that was stored in the chemical bonds is going to be released. So you can remember exit sounds like exo. Exothermic energy exits. There's going to be more energy in the reactants, because you start with more energy than you end with. If you sketch that graph with reaction progress and then energy, we have energy in reactants, activation energy, and energy in the products, and the energy in the products is lower than in the reactants. And then finally, delta H. For exothermic, energy is being released, so delta H is negative. Energy is leaving those chemical bonds. So in this example over here, this question, it says the reaction occurs and energy is absorbed. That's energy entering, enter, endo, so this is endothermic. Next, let's look at this graph. We'll figure out if it's exo or endothermic. We have reaction progress on the bottom, energy on the y-axis. We've got the reactants here, and then the products up here. And this peak in the middle is the activation energy that has to be there for the reaction to start. You can see the products have more energy than the reactants. That means energy entered. That means it's going to be endothermic. And the last question in this problem set of examples says delta H for the reaction is negative. Is it exo or endo or exothermic? Well, if delta H is negative, that means there's less energy at the end. That means energy exited. So that means this is exothermic.